Okay, well, thank you for attending the deep dive to NATS. We're happy to see that already some production users. For NATS, we joined the CNCF last year and has increased in popularity since last year, well, a lot. And more than a third of the maintainers into the project have increased, and also the contributors. So it's exciting to be here. And also, just a trivia, last year when I was at the KubeCon Europe in Copenhagen, my laptop broke just 1 hour before the talk. So it's kind of like the revenge now. Okay, so this is a deep dive into NATS, and I'm going to focus mainly into what is coming next in the big release for NATS version 2. Quick note about myself. My name is Waldemar Quevedo. Find me on Twitter on WallyQS. I'm a software engineer at Synadia Communications, where many of the maintainers for NATS are working right now. I've been using NATS-based systems since 2012. I started with Cloud Foundry, doing operations with the Ruby version from NATS. And I'm very happy with the projects. I think it's a very fun project to be a part of. And I really like the philosophy of simplicity for NATS. So also last year, I wrote the first book for it, in case you want to take a look. It's practical NATS, and it covers mainly all of the features from NATS version 1. So I need to start looking into an update for NATS version 2. So in this talk, two main things. How many of you are using Kubernetes? Well, I guess it's KubeCon, but okay. And using the NATS operator? Well, NATS operator, okay. Cool. Yeah, so I'll give a quick overview of the NATS the most recent version for NATS operator is ready for using the NATS v2 features. So I'll just go quick over those. So announcement, NATS version 2 now has a date. It's going to be released on June 10th. And we have been running a service in production with all the features from NATS v2. It's called NKEYS. And so it has been, we launched that on KubeCon on December, so it's already been close to 6 months in production, running in production. So we're very close to ship it. Now I just finished on the documentation. Want to ship with documentation from day one this time. So yeah, now has a date, and just a little bit more wait for us tagging the repo, because everything is open source and everything's in master already if you want to check it out. So questions from yesterday, just let me know, raise your hand. Or, yes? Sorry. Yeah.
With the new NATS v2 clustering, does it work to, for example, make sure that you don't have too much talk between different NATS streaming servers connected to different geographically located NATS clusters? So say I have a NATS streaming cluster, or do I deploy different NATS streaming clusters, or can I have a single NATS streaming cluster for multiple NATS v2 clusters? Or what would be the general way of doing that?
Okay, so in case, well, I guess that question might be better answered when I talk about the superclusters. So the question, well, I mean, we can hear it, is how does NATS streaming would work once you have the superclusters, I guess? Yeah? Okay, then I'll touch on that when I talk about superclusters. Okay. Okay, thank you. So NATS version 2 is a very important release for us, because it's NATS, it's now taking a leap from being a technology that remains within a single data center in a silo, and it's now can be used as a core component to build a global communication network, kind of like a backbone, with the goal to provide an always available dial tone, kind of like a global utility, that single URL that you can just connect to and start communicating, sending messages, requests. And in our case, this is the URL, telnet. Well, you can telnet, but you need a proper client for NATS, connect.ngs.global on the port 4222. If you want to try, we'll disconnect you in the Go client. So this is a list of all the features that are shipping with NATS version 2, starting with the most notable one, which is the multi-tenancy features and accounts. We call them containers for messaging. In order to achieve that, we had to, it was the clustering, the routes had to be rewritten. But for the clients, the protocol is 100% backwards compatible, so that's OK. We have two new abstractions that we'll be adopting when talking about using NATS. These are streams and services. You are using NATS, you are already using this. We just started to name these patterns of the request response and just sending data streams. There's a security and auth enhancements. One's called NKEYS, which are 825519 keys. The superclusters that we're talking about, which gateways and Leafnodes and basically clusters to clusters. System accounts for operations for these very large clusters when you can use NATS to be able to monitor all of the servers that are part of the network. And decentralized management, instead of having a single static configuration that you can do reload to dynamically update. Now for the authorization pieces, you can have you can decentralize those permissions. And last but not least, the graceful shutdown. So first, multi-tenancy and accounts, which are, we like to say they're like containers for messaging. You're familiar with the NATS version 1 authorization features. We have, you can define a stanza for authorization and list a number of users that are allowed to be able to connect into the system. And that was like a static list of users. And all of the subject namespaces were shared. So if you wanted to separate the permissions, you could, you could start using the permissions definition to be able to declare whether this set of users are allowed to only send requests on this subject, but they're allowed to be able to, they're not allowed to subscribe or act as responders for this other service. In this case, if you do the connect and publish a message, for example, in this case, the user Alice, it would get an asynchronous error notification that it cannot publish messages. And the other one is getting a notification that it cannot subscribe. So this is still very useful. But now there's a more flexible way to create like pool of users and separating them into multiple accounts. In this case, you have a couple of accounts, one ACME and CNCF. And they have a single user for each one of the accounts. Now, if the Alice connects, and it doesn't, Alice doesn't have to declare which is the account that is connecting, but rather the server knows to which account it belongs already by only sending the credentials. So in this case, Alice can connect to sub-greetings, and then Bob, under the other account, can connect and publish messages, but because the subject namespaces are isolated, then there is no data sharing by default within these two accounts. So in this case, the message is not forwarded. So this can be a very easy way to be able to reuse a single NAT server for multiple set of requirements. As you know, the NAT server performance is fairly high. So you can, by default, it's around 80 million messages per second on very beefy machines. So you can start, rather than separating into multiple clusters, you can just continue to use the same set of IPs or reuse the same data set, the NATS cluster setup. And in order to support this clustering, the accounts isolation, the routes how to be rewritten. And this is the only part that is not compatible with NATS V1 deployments. And the reason for that is that, well, now to upgrade from NATS to version 2, then your clients will have to have a disconnect to the NATS version 2 clusters, and you cannot connect them version 2 cluster to NATS version 1. So if you're using NATS operator, there's a feature named extra routes, so you can connect to other clusters so that you can drain one cluster and then upgrading. So this is unfortunately not possible when moving from V1 to version 2. So now the routing protocol looks like this. whenever you are creating a subscription, it gets announced within the same NATS cluster. In this case, the hello subscription from the first connection is being gossiped. Well, the interest is being forwarded to the other NATS members from NATS cluster. And you see that there is now this $G account. So even if you're not explicitly using accounts, you are already part of an account. If you start using NATS v2 as if it were NATS v1, what actually is happening is that you're using the global account where all well, implicitly using the global account. So the next feature is that sharing data between these accounts. For this, you use the streams and services abstractions. Again, services is what we know in NATS as any endpoint, that is any subscription that from a requester is expecting a response. That is a single response. That is a service. And a stream is essentially just a subscription that from which you can consume events. In this case, we have the two accounts, the ACME and CNCF accounts with the Alice and Bob users. You need to, very similar to like in containers, you need to export the ports that you want other services to connect. You need to export what are the subjects that other accounts are able to mount into their own isolated subject namespaces. So in this case, the ACME account is making available the hello subject, and then the CNCF account, it is importing from the ACME account the subject hello and mounting that subject into the CNCF.hello subject. So considering that isolated pieces, now the Q subscription that is acting as a service. Here we have the hello subscription using the worker Q group that is expecting a request with a reply inbox. Then, from the CNCF account, you make a request on the CNCF.hello subject. That is where you mounted that subject from that other account. Any questions on this part? Okay, so what is really cool about sharing data between these accounts is that the request response, are you familiar with the way that NATS does request response one-to-one and communication? It does it by having these ephemeral inboxes. So NATS there's no special request response protocol for NATS. Everything is pure public subscribe. So the request response is built by having this unique identifier for an inbox that has very limited interest for a response, for a message. So you can see that the original client sending a request on the CNCF.hello subject that belongs to the CNCF account. But when it moves across accounts, this gets transformed into another ephemeral subject. So between the different subject namespaces, they're completely unaware of what was the original subject. So that doesn't leak between accounts. So the request response is completely anonymous. Then the other abstraction when you're using accounts and NATS is streams. And streams, similarly, we can declare in the exports that this is a stream that you're making available for other accounts under the acme.full wildcard. And then the CNCF account can import this stream that belongs from the ACME account into imports namespace. So now any message that gets published under the acme.full wildcard, anything that matches with the full wildcard, in this case would be hello, but it could be any number of subject separated by a dot. They would be consumed by the other CNCF account under the imports.full wildcard. Okay, so far we have still been using the users basic user and password credential static configuration, which is a NAT server. We have a new technology named NKEYS, which are based on 825519, very short keys. And these are, we added a couple of encoding for the raw 825519 keys to make them easy to use. And this is what you can, you can use this public and private key mechanism to authenticate the users instead of the basic users. So there is a NKEY tool that you can use, go get, to be able to generate these private keys. This is an example of creating a user key. You can see that starts with an S, U. It's a seed that can act as a private key, and is that what you can use to generate the key pair that you can use to sign messages and payloads or verify the payloads. From this seed, you can create a public account, and the public account is the one that is, well, actually gets transmitted to the NAT server, for example. But the NAT server doesn't hold any private keys whatsoever. So it doesn't have, it only sends you challenges that you have to sign, and then then the NAT server will verify that the challenge is valid, and you can authenticate. So it's an example of replacing the user's user and basic password that we had with the NKEYS. So you declare still using static configuration, you declare the public key from the NKEY, and I just have commented here what is the seed. But the seed, you actually have to be very careful. It's a secret, essentially. So you have to be careful how to manage that, and basically never make it public. So now that we have NKEYS and have a public and private key way of authenticating with the server, the next piece is making the static configuration decentralized. So for this, we used JWTS, the JSON Web Tokens. So you can represent the identities that belong to the system. So you have, as part of some of the fields from the JWT, there is which account this user belongs to, what is the public NKEY. There are some more metadata like friendly names and the permissions that this account has, and some expiration parameters as well. This is how they look. You're familiar with JSON tokens. In this case, what I mentioned at the beginning for the permissions, as part of the JWT that gets issued to you by someone, it detects that you can only publish messages under the public.full wildcard, and you cannot subscribe to anything that is under the private.full wildcard. And these JWTs are stored in something that we call the NATS account server. So now the NATS server gets configured with a resolver, which is an HTTP client that makes a single GET to fetch a publicly available JWT in order to validate whether this user can connect to the system. The idea is that these endpoints will eventually be part of a CDN, and so you can, thanks to the CDN, that GET request gets handled by the closest server to you. So this is not like private data. It's meant to be holding public JWTs. And there's this new tool, NSC, for creating these JWTs as well. The complete documentation for all this tooling is coming very soon as well. Just you can already start checking out the repos that are part of the NATS.io organization. So in a nutshell, how it works with NKEYS and JWTs is that as a client, you start the connection, the server sends an info protocol back with a challenge. You, as a client, then send the connect request, the connect payload, signing the challenge with the private NKEY that you have. And you provide the public NKEY, and in this case will be part of the JWT. Then the server verifies the signature and then allows you, gives you access into the system based on the permissions that were assigned to you. And it does, in that way, the server doesn't have any private keys whatsoever. This is an example of the flow. There's a nonce that gets sent by the server. the full JWT gets added as a part of the JSON payload from Connect. And this is the signature that you send back to the server. Okay, so now about super clusters and basically cluster of clusters. The clusters of clusters rely on a technology named the gateways. And a gateway is a new type of connection that can be either outbound or inbound. So in this case, there is only per data center. Each one of the nodes has only a single connection to one of the other data centers that are part of the super cluster. This is how you set up, for example, the set of gateways. In this case, have 3 different data centers, Amsterdam, Bangalore, and New York. And it connects to one of the servers that are part of from that cluster, and then there's also gossiping happening under the hood. So it would discover what are the other, similar to how it works with the NATS cluster, and you can get asynchronous info messages to discover the full network topology. Similar thing happens with gateways, so you can ensure that there's inbound and outbound connections to be able to not have partitions in the messages that get routed. This is an example of, well, the 3 different data centers. When you connect to them, they announce to you what are the available clusters for that data center. So now you come from Amsterdam, you get 3 different public IPs, and NYC you get 3 different as well. And then if you publish from the 3rd one, then the message will get routed to the other data centers above. And this goes in line to the original question about NAT streaming. The Q subscriptions for when you're using super clusters, they are geo-aware. So in case you have a NAT streaming cluster, it would be only handling the requests that are part of this the one data center, unless let's say you have they fail, and then another data center would fail over, basically, even if they're very far. So, but by default, it will try to optimize what is the closest subscriber or consumer that can reply to the message. So in this case, it was only until the 2 Q subscriptions that belong to the Amsterdam data center failed when the New York data center started to handling the traffic. Yeah, it does it by, well, it is aware of the round trip times from the ping and pong protocol. Okay. So there is the way that that supercluster works. It is at most 3 hops whenever the message is getting forwarded. So when you connect to any of the nodes from the supercluster, the message gets routed and also goes from account to account. So it builds on top of the previous pieces that I already mentioned. And there is an extra type of network topology using Leafnodes, which is when your client, you can use like Dumber clients to connect to the superclusters without having to rely on the NKEYS or these other features. So you can just have this extra Leafnode handle that for you. It was similar. And system events is a very helpful feature to be able to do operations for this mesh of clusters. In our case, because we were using a supercluster that is composed from around 7 different Kubernetes regions, AKS and AWS, GKE. And so rather than doing operations with multiple kubectl commands, we just rely on use more NATS to be able to collect all of the requests and monitor using the system account that is that gives you visibility on a number of stats from the server. So this is it's very useful. The system account has a number of subjects that you can send a request and then expect n number of replies back with information about each one of the nodes that are part of the supercluster. This is an example payload that you can inspect from when subscribing to that sys.server. And also, this was done quite a while ago, but it is getting shipped with NATS version 2. It is the lame duck mode, when by sending a user2 signal to the server, now the servers are going to gradually be disconnecting all of the clients that are connected so that they can reconnect to any other available node without. So that it is helpful to be able to drain traffic from one, for doing updates to NATS, basically. That's what we do now. So deploying NATS version 2 on Kubernetes using the operator. So this is NATS operator composes many of the best practices from running NATS in production. And the last release has the pieces to be able to create gateways, Leafnodes, and run the NATS server in the trusted operator mode. This is how the manifest looks like when you want to, or the way we're right now recommending to, if you want to create a supercluster on some of the publicly available clouds. We use the host port to be able to bind a single port to each one of the machines. So you have to, if you want to have external access with the operator, you need to ensure that as part of the nodes metadata from the kubelets, there is the external IP. Sometimes it's missing, but I think well, it used to be missing in NKEYS, but that got fixed. So I think most of the current deployments do. Public hosted Kubernetes solutions are already supported. You define what are the gateways based on a public IP. In this case, I'm only assigning a single public IP and then rely on the gossip to be able to discover the other clusters. But it could be helpful as well to have a DNS name that resolves all of the different gateways that resolve into that cluster, so that the NATS server will do that for you. So to avoid relying on the public IP that can change. And this, and if you're using version V1.12, we rely on the feature of the sharing process namespaces, so that you can reload the configuration from the server on the fly without having to restart it. So a NATS operator creates three, in this case, it's size 3, so we would create a 3-node cluster, and it assigns a single A record for each one of the nodes, which is very important if you want to set up TLS, because you need to create a wildcard certificate that matches this. In this case, it would be the NATS supercluster MGMT. And now, as part of the README in the NATS operator, someone contributed how to do that using the cert manager, and that's super useful. That's not what I've been using lately. And by setting this, this is what I mentioned about the external IP metadata has to be available. The way that this is also relying on having a service account that has enough permissions to be able to resolve the external IP. It's just an initialization container that finds what is the IP from the current NATS server node where it has been deployed, and then sets that at runtime so that it can advertise what is the IP address. It's a little bit involved what it does, but it's automated with the operator. But this is very useful so that you can, your clients, if you're connected externally, they can discover the other publicly available endpoints without relying on DNS anymore. And for the trusted operator setup, there are basically 3 different parameters you need to set, which are the system account, which is the blessed account that you can use to be able to monitor the servers, the special secret that contains the private key with the for the trusted server setup, and the endpoint from where it's going to be validating that the JWTs that it gets are, well, we're going to be fetching the JWTs or the NATS account server. And this is what I mentioned about that, a simple tool that you can use just using the system account and the superclusters and NKEYS to be able to discover what are the current available nodes as part of the cluster. So far for the features, I can I'll have a deployment for if you want to see how it works. But any questions so far? NTP?
How do you handle the latency between clusters? So how do you handle the consistency of the data if you have multiple timestamps?
Well,
so you have multiple clusters, so
yeah.
you have multiple timestamps in different clusters. How do you handle to do the replication and reconcile the messages?
Okay. So that's so NATS is stateless, and it doesn't have it is not coupled to any timestamps in this case. So I think it's for NATS I think it's a non-problem right now. That's NATS. Okay, well, NATS streaming, yeah, it does have the notion, well, the timestamps, but is I guess for NATS streaming, the current type of deployments would be within a single data center. Not sure. We need to ask Ivan on how to deploy it with a multiple supercluster setup as well. Yeah. A full mesh means that the NATS cluster, it's for high availability purposes. For example, each one of these NATS clusters, small NATS clusters, they are a full mesh. So full mesh one hop, and then the superclusters, they're not full mesh but have the outbound connections. And yeah, but the communication for NATS, the core NATS is stateless, so it wouldn't have the issues around timestamps or yeah. Yes.
So NATS supports amazingly well for permission-based authorizations, but NATS streaming server doesn't. So is there any plan of adding that? Or is there another new version for NATS streaming server?
Yeah, that's still in design. Yeah, it's a limitation from NATS streaming that it doesn't have authorization. And so, yeah, we still have yet to address that issue.
Okay.
Yeah.
And so is there any improvements on adding PV per pod for NATS server?
Adding what?
PV per pod.
PV per pod? For NATS streaming server, right?
Yeah.
That's okay. I think with the Helm chart, right now it's supported, but with the operator need an enhancement on that one. Yeah, so it's, yeah, right now it's pending.
Okay.
Yes.
Thanks for answering.
Okay. Any other questions? I also have stickers if you want. Yeah, so I'll also be at the CNCF answers bar if you want to talk about your use case or a more interested on their angle of using NATS, just let me know. Or DM me on Twitter as well. Well, thank you.